In question 17 we're told that Hugo competes in high jump at school. He has 3 attempts, first one, second one, third one, to clear the bar at each height. When he clears the bar he doesn't have another attempt after that, so if he does it in the first go he won't have the second and third subsequent goes. When the bar is set at a height of 1.6 meters, the probability that Hugo will clear the bar is 0.4. The probability tree diagram below shows the outcome of Hugo's attempts. Now what they want us to do in part A is to complete the tree diagram with the 4 missing probabilities. So we know, which makes it quite easy, that at any stage, irrespective of which attempt it is, the probability that he clears the bar is 0.4. So therefore we know that each of these top ones is 0.4. We also should remember that in any individual event such as this first attempt, the probabilities will have to add up to 1. So if the top one is 0.4, we know the bottom one will be 0.6, and similarly this will therefore be 0.6 because the probability of clearing it is 0.4, and again this one is 0.6 as well. So the tree diagram is actually quite easy to complete, and hence why there's only 1 mark for it. In part B then, we're asked to work out the probability that Hugo does not clear the bar on his first 2 attempts and then does on the third. So therefore what we're actually looking for is the probability that of not clearing not clearing on first 2, then clearing on third. So that's what we're looking for in terms of probability. So if you go up to the probability tree diagram, essentially what we're saying is he doesn't clear it, then he clears it. So it's not clear, and not clear, and clear. And when we say and, as you remember, that means the and rule tells us to multiply. So essentially what we're doing is we're saying probability of not clearing, which is 0.6, multiplied by the probability on the next go that he doesn't clear it, which is 0.6, multiplied the probability that he does clear it on the third attempt, as it says there, which is 0.4, and when you multiply that together you get 0.144. Now we're told that Hugo clears the bar at 1.6 and it's raised to 1.65, and again he has 3 attempts. And it says that at this time, when it's set at 1.65, the probability that he clears it is 0.3. So in much the same way, if we just do the same diagram again, just to make it easier, so we've got first attempt, not written very well, so we've got first, second, and third attempt. And what we know, it's literally going to be, clear, not clear, and again if he clears it he gets another chance to clear it, or he again not clears it, and then he gets a third chance to clear it or not clear it. And what we're told about that is that the probability of clearing in any attempt 0.3, therefore of not clearing 0.7, 0.3, 0.7, and again 0.3, 0.7. And we're asked then to find the probability that Hugo clears the bar at 1.65 meters. So the probability that he clears it is equal to, so how can he do that? Well, he can either clear it in his first go, or, and that or again is key, remember, as part of the or rule, or he can not clear it and then that's an awful ampersand, isn't it? And then clear it, or he can not clear it in his first one and not clear it in his second one, and then finally clear it in his third one. The or again is critical because that tells us we add it. The and is critical because that tells us we multiply it. So the first bit, which is the probability that he clears it, well, we know that that is 0.3. Then it says or, so we add that, and now we need to do the probability that he doesn't clear it multiplied by the probability that he does. So it's 0.7 times 0.3, and then finally again we need the probability that he doesn't, and then he does in the third go. So again it will be 0.7 times 0.7 times 0.2, and that will give us 0.3, or plus because it's the oral, plus 0.21, which is the 0.7 times 0.3, plus 0.147, and that gives us a total probability of 0.657.